Chapter 6, you have two questions over interval estimation. Sorry about that. And I just want to remind you that you can work through these problems with me, but to make sure that you use the values given in your question, because we're going to have different values. And if you just plug my answers in to your assignment, you're going to get them wrong. So I'll provide you with the spreadsheet I use here, but make sure to change the values to your percentages. So the first thing I had to do was open this file because I need to actually use the data from there. And I'm told that there were 1,000 surveys. So I know I have a sample of 1,000. And that a responsive yes indicated that the adults think that today's children are better off than their parents. And a responsive no indicates that they do not believe that. And that there was 23% of them said that they were not sure. So what is the point estimate of the proportion of adults who think that today's children will be better off than their parents? And remember to always watch how many decimals it wants you to round your answer to, because it changes often. So the first thing I want to do is determine what is my point estimate? How many think that, what is my proportion? So I know that I have a sample of 1,000, because the problem told me that. But how many think that the children are better off? We're going to go back a couple of weeks on this one, and to determine this, I am going to formula COUNTIF. So for A, and I'm going to say how many said yes. So I have 240. So to determine my P, oops, I didn't want to print. I meant to do Control I for italics, and I did Control P. So I need to know what proportion is 240 of the 1,000. So 240 divided by the 1,000 tells me that that's a 0.24. My P is 0.24. And so that would be my answer there, 0.24. Now I'm asked to, at a 95% confidence, what's the margin of error? Okay, so to determine this, I'm going to have to plug in some other things that go here. And what I'm going to need is my confidence coefficient. I'm going to need my alpha. I'm going to need my Z. Make that a big Z. No, right? Okay, yeah. Z when my alpha is divided by 2. And that will give me a standard error. Or I will use those values to give me a standard error. So the margin of error will come from my standard error. And if we go back to the text and we refer back, if we think back to chapter 1 when we talked about normal distribution of data, this is a very powerful paragraph in your book. And I am under interval estimation of population. You want to commit this to memory. So what it tells me is that for normally distributed random variable, 90% of the value lies within 1.645 standard deviations of the mean and has a z of 1.645. 95% of the values lie within 1.960 standard deviations and has a z of 1.96. And for 99% of the values, they're 2.576 standard deviations from the mean and have a z of 2.576. So this is a very powerful paragraph there. It's really short. So my confidence coefficient in my question is at 95% confidence. So my confidence coefficient is 0.95. Now, to get the alpha is always going to be 1 minus your confidence interval. And remember, for my z, it said 1.96. At 95%, my z is 1.96. So I can put 1.96 in there. Then to determine my standard error, I need to work the equation that's on the next page right here. So I've put that equation here somewhere. I think I put it on this page. So let me copy that over for us so we can reference it. Let's say standard error. Okay, so we're going to plug this in. So my standard error equals the square root of my p times 1 minus my p divided by my n. And I believe I'm supposed to go 4 digits on this, so let me get there. So back to my question, at 95% confidence, what's the margin of error? Okay, so to get the margin of error, I take my standard error times my z. So my margin of error at 4 digits is 0540. Then it says, what is the confidence interval? What is the interval? So we know that the margin of error is 0.0540. So to get our interval, it means that we're going to have a low end and a high end. And those are simply going to be of the p. So the low end is going to equal my p minus my margin. And my high end is going to be my p plus my margin. Oops. Don't do that. Escape. Okay, here, equals p plus my margin of error. So that's going to be the answer here. Then it says, what's the 95% confidence interval for the proportion of adults who do not think that today's children are better off? Okay, well, just to answer that short little question, I've got to determine all of this stuff all over again. And let me change this to make this column better and this column worse. Okay, so out of my 1,000, I need to know how many felt that they were worse off. So again, I'm going to do my count if. my A, and I'm going to say no. So my P is going to equal 530 divided by 1,000. My confidence interval is still 0.95, which means my A is still 0.05 and my Z is still 1.96. Now I can plug in my formula, equals square root of P times 1 minus P divided by N. No, we don't need your help. We just need to click the right cell. Oh, I see why. Divided by. I had my shifter on, huh? And there's that answer to 4 decimal places. And so my margin of error is going to equal my standard error times my Z to 4 decimals. And then my high and low for this is better and this is worse. So here my low is going to be my P minus my margin. Did it again. Go back, escape. Okay. Equals my P minus my margin of error. And my high is going to be equals my P plus my margin of error. And then it's going to ask you to make some conclusions about the data based on what you have on your spreadsheet. Okay. Then question 4 is staying on the same topic of interval estimations. And question 4 says that the Pew Research conducted a survey of 857, and the sample showed that 90% of those felt that the internet's been a good thing for them. So the P in this case is 0.9 for 90%. So to get my N, I'm going to say how many of that. So it's going to be my N times my P gives me my little n. And it wants me to develop a 95% confidence interval. So my confidence coefficient is 0.95, which I know means my alpha is 0.05 and my Z is 1.96. And I can get my standard error from plugging in this equation equals square root of P times 1 minus P divided by N. And so now I can get my margin of error by saying standard error times Z. And I can work my high and low by saying equals P minus my margin, and then my high is going to be P plus my margin. Then it says 67% said that the internet has strengthened their relationships, and it wants us to do another 95% confidence interval. So we still have the same sample size of 857, but now I'm looking at 67% of them. So my N is going to equal my big N times my P. My confidence interval, my alpha and my Z are all going to stay the same. And now I can plug in the formula to get my standard error. So it's square root of P times 1 minus P. Should have this to memory by the time you're done with this chapter. Divided by N. And then to get my margin of error, I take my standard error times my Z. And now down here, strengthen my low will be equals my P minus my margin of error, and my high will equal my P plus my margin of error. Then it says 56%. They've have seen an online group come together to help solve a problem, and 25% left an online group because of unpleasant interaction. Develop a 95% confidence interval for the proportion of internet users who say online groups have helped solve a problem. They threw that 25% in there just to distract us, I think. So we'll work a 95% confidence interval using 56% as our P this time. So I'm going to leave that one to you to work, and then it wants you to draw some conclusions based on your spreadsheet that you've got here. So that is it for those two questions, and I will have another video to go on to question 5, where we're asked about hypothesis testing.